Hello everybody, today we will be entering chapter 5 which is on electromagnetic induction. Wait, let me just check if I've turned on the microphone. Yes, I did. Alright, so now there are 5 subtopics in this chapter. The first one is on magnetic flux. So in this subtopic, you have to be able to define and use magnetic flux, and lastly, use magnetic flux linkage. So apa tu magnetic flux? Magnetic flux is the symbol dia adalah phi, and it is defined as the scalar product between the magnetic flux density with the vector of the surface area. Okay, so please remember ini adalah magnetic flux density. Magnetic flux density adalah B. Lepas tu kalau dia cakap magnetic field strength pun B juga. Macam tu lah. Okay. And then the vector of the surface area, please remember that it will always be normal to the surface. So for example, for this case, it will be normal to the surface. If it's this way, it will also be normal to the surface. So any surface, they will see normal to the surface ataupun perpendicular to the surface. Magnetic flux ni also known as the number of magnetic field lines that passes through a given area lah. So the formula is phi equal to BA cos theta lah. Ini adalah formula. So it is given in your formula sheet, so it's not really a problem for you. Sebab you don't have to remember the formula lah. Okay. So untuk this chapter, please remember that the angle ni banyak lah. So basically all the formulas have angle. Almost all lah. So the angle ni, the definition of each of this angle is not the same for each chapter lah, ataupun for each formula dia tidak sama. So untuk this magnetic flux ni, the angle is the angle between B and A. Okay, so it is the angle between the magnetic field and the vector area. Alright. So it is a scalar quantity. It has the unit of Weber ataupun Tesla square, Tesla meter square. Macam itulah. Alright, so let's look at this situation here. Oh, I've cropped some of it. Is that a problem? It's okay lah, malas mau fix nanti. So, if we look at the first situation here, the vector area is parallel to the magnetic field lines. So, theta will be equal to 0, and we know that cos theta will be equal to 1, which give us the maximum magnetic flux. Okay, so if vector area and the magnetic field lines are parallel to each other, we will get the magnetic flux to be at a maximum. Alright, so if we look at when it is at an angle, so we know that the angle theta, the theta is the angle between the magnetic field lines and the vector area A. So it's going to be 60 degrees. So substitute je lah dalam ni. So it's going to be phi equal to greater than 0 lah. Dia bukan equal to 0. So untuk when it is perpendicular, when the vector area A is perpendicular to the magnetic field lines, it will be equal to 0. Phi is equal to 0 because cos 90 is equal to 0. Okay. Alright. Okay, so now let's look at magnetic flux linkage, which is the uppercase phi. So it is a measure of the total magnetic flux passing through a coil with a certain number of turns. So the formula is given here. I think it's also given in your formula sheet. And yeah, that's basically, phi is basically the magnetic flux passing through one turn. So the uppercase phi is telling us the magnetic flux linkage through a number of turns lah, banyak lah number of turns there. Okay, let's look at example example number 1. Alright, so given is the area, which is, I think I should make this a bit smaller. So area is given as 3 centimeters square, so that is to the power of negative 4 square. And then if the magnetic field strength is 6 Tesla, so that is B, yeah? The symbol is B, and then making an angle 30 degree with the surface area. So for example, let us draw this. Okay, so sekarang ni dia cakap the magnetic field strength makes an angle of 30 degree with the surface area. So basically, if this is the magnetic field lines, this will be 30 degree. Okay, so that is 30 degree. So sekarang ni kita tahu kita punya vector area A is always normal to the surface. So sekarang ni kita perlu cari this value of theta. Okay, so this is the theta lah. Sebab kita punya formula is BA cos theta. Sebab soalan minta magnetic flux through this area. So, berapa nilai theta ni? Kita tahu theta will be equal to 90 minus 30, which is equal to 60 degree. Kenapa 90 minus 30? Sebab this is perpendicular ataupun normal to the surface area. So, from here, you will then get the value of 6.53 times 10 to the power of negative 4 Weber. Okay, so the formula is Weber. Sorry, it's wrong. It's 9 times 10. 9 times 10 to the power of negative 4 Weber. Alright, so that is the answer. Example number 2, we have a coil with 500 turns. And then it has a radius of 2 centimeters, so that is 0.02 meter. It is placed in a field of 0.6 Tesla, such that there is an angle of 30 degree between the field and the normal to the cross-sectional area. So that is basically telling us the angle. So it is equal to 30 degree. Calculate the magnetic flux and the magnetic flux linkage. So phi is equal to BA cos theta. So we know that area is pi r square. So kamu substitute all the values here and you will get the phi to be equal to 6.53 times 10 negative 4 Weber. Okay? That is 6. So that is the value of phi. Next, we have to calculate the magnetic flux linkage. So that is uppercase phi is equal to n darab dengan phi. Lowercase phi lah. So this one you just substitute 500 darab lah dengan 6.53 times 10 to the power of negative 4. You will then get the value of uppercase magnetic flux linkage to be equal to 0.33 Weber. Okay? Alright. Yeah, so this is all of subtopic number 1 lah. This is basically what you need to know. In subtopic number 1, the most important part is applying this equation into some problems lah. Okay, so kamu perlu apply and then solve using this equation. Yeah, so basically these two equations lah kamu perlu tahu. Alright, that is on subtopic number 1.